Hey guys, how are you? Hope you will be doing fantastic journey with your software development field. And myself, Console Cooker, and today I come up with the one fantastic session on architecture evolution of Facebook feed system, right? So basically, I am the solution engineer, or you can also say the data engineer or solution engineer, working in the hypertrains globally, and I got one opportunity to present this uh, huge mighty system, right? Complex system that is Facebook, and how behind the scenes, right? This Facebook system works. So that is the core agenda of today's session. So let's start with the introduction. So basically, what is the Facebook feed system, right? So mostly the peoples like us who are in the working environment of software companies, and they are very common, they are aware of the Facebook feeds, right? So basically, when we open the Facebook applications, when user opens the Facebook applications, at the landing page you'll see the number of posts that is inserted, or that is fit to the user, right? So that informations which you can see on your landing page is nothing but the feeds, right? So those feeds will be from the friends, that will be from the pages you follow, that will be from the community you like, or things like that. So basically, there are some algorithms, there are some sort of rules, and based on those rules, you will be feeded to the different data, right? So I say data, so data is nothing but the post, and post inherently will have the text, and then the images, and then the videos, and then like and comments and everything. So to do this, to provide this feature to the end user, Facebook does a lots of background work. So basically, it is very critical task, right? So that is the core objective, to uh, to understand the basic principles of that Facebook feed system, and how it's work behind the scenes. So basically, in this session, I'll be covering key topics, that will be architecture components. Will be starting this architecture components is not directly related to the Facebook, but just to move ahead in the right direction, we'll create some common ground, right? First, so on based on that foundation, we will create a the session, right? So basically, we'll be discussing some common architecture component first, then we'll switch to the requirement analysis. What is the actual requirement to have this feature, right? This feed system. Then we'll play with some processing workflows, how actually the request, create request or retrieval request is triggered from the applications, and how it propagates through whole cycle, right? So that will be seen in the processing workflow. Then some actual data that I'll be sharing. So it's just a data, nothing else. But just to realize how complex it is, we'll be sharing some data, and then I'll be switching to TAO. That is a game changer, right? So really, it is key element to understand for the Facebook feed system, and then some references and question answers needed. So basically, this is the flow that I'll be providing to you, right? So let's begin. And are you guys excited for this? Of course, you'll be excited as like me, to grab these underlying concepts of Facebook, so-called Facebook feed system, right? So, yep. So that's it, and let's begin the show then. So this is the one of the architecture model that I want to present to you. So this is push model, right? So imagine the scenario. not only for the Facebook, right? In general, imagine the scenario: one user which is producer, and other is the consumers, right? So basically, these are the common scenario, common use case we have in the software industry. So there will be one producer who will be producing the data, and there will be some consumers, right? So will be consuming some data. So this cycle, starting from producer to consumer, right? So this cycle has different mechanism, different patterns to complete, right? So in and out of those patterns, this is one of the pattern, push model. So what is push model? Basically, it has three major components. Post generation, that there will be uh, one system or one applications which will be useful for generating a post, right? So basically that post will be generated. So that is first part. Then second is data processing. Once that post is generated, some queuing system or anything, server, backend server, we can have different variations of that too, but some server or queuing system will process that data and then finally ingest that to the targeted database just to store it permanently. And again, database variations can be different. It can be an SQL type, it can be NoSQL, it can be AWS. In context of AWS, it can be DynamoDB or anything. But there are variations. It can be object types. But this is the data processing. It will be stored to the database, and once that is feeded, that is processed and ingested to the required database, final step is consumer who wants to consume that data, right? So in the push model, what is the main difference? The data is proactively processed. I mean, proactively it is processed in such a way that whenever consumer wants to consume, wants to retrieve that data, it is readily available. So it is already prepared and stored in a such a way that it is just to just we can retrieve at the trigger of consumers request, right? So when consumers want to retrieve, we don't do much processing, we just fetch it from the database, right? So this database, so basically all the predefined or pre-calculations that is done, and then the final version of the data is stored here. And this is the basically push model. And as you'll be thinking, the next is pull model, that is counterpart of this. Process is same, producer is producing the data and consumer is consuming the data. In the whole this cycle, there will be post generation again, that will be processed and ingested to the database. But what is the main difference is, here is in the pool model, instead of proactively calculating the data and ingesting them to the final database from which the consumer consumes the data, instead of doing that, we are actually fan out, we do a fan out on low. The pull push model is different, right? It is actually fan out on write. Basically we write on the right side, we do have multiple fan outs. I mean, we are triggering multiple process. Fan out means in the one request we are fanning out to the multiple requests. So basically that is on right side, push mode in push case. In pull case, that is on read side. Basically consumer will request for the data, that request comes to this modifier. Of course this modifier will be, you can imagine it as a server or whatever, right? So that will come to this, then that modifier will again, and maybe it will trigger multiple processes, maybe it will trigger multiple http requests, and those multiple http requests eventually will gather the data from different databases, do some aggregations, filtering, and everything, and then it will provide to the consumer. So that process, right, of aggregations, of filtering, or consolidating the different data from the different databases is done at the request side when the request comes. So this is, that is why it is pull model. So that is the fundamental difference of these two models. In general, there is no rocket science here, or no all fit to all model, right? So it doesn't like push model is the highest possible approach, or pull model is the best fit for all solutions. So it depends on the requirements. Both of this architecture has its own limitation on, or in its own advantages, right? So if we talk about push model, then it is proactively calculating a data, and when at the time of retrieval it will just fetch from the ultimate storage. So that is very easy. But what is it owns disadvantage is it has to perform on every write operation, right? It has to trigger that pre-calculation cycle on every write operations. So that is the resource overhead, the cost is the factor. And what is the advantage of pool model? We on the write, just write the data to the database, and then at the retrieval we'll just calculate the do a calculations, right? So what is the advantage of this? It has less resources used, and but what is the disadvantage? Of course, performance, speed, latency. So that is a disadvantage. So both of these models will have a different perspective and advantages and disadvantages. Some of the scenarios we use a hybrid approach also, right? In some use cases, in the single system we apply both the model, but that is known as hybrid. For some consumers, we can have the push model pipeline, and some for some others we can have pull model. So that is why we leverage these both architecture models. So this is good to know. And I want to also highlight some key questions, right? So if we are designing any system, so before designing we should ask some questions to ourselves. So in case of this Facebook feed system, what are the questions we can ask to ourselves? So that is first question. Are there more producers than the consumer, right? So basically producers are higher or consumers are higher. This is a straightforward answer. Of course, in the case of Facebook feed, there is higher number of consumers than the producers. What is the maximum acceptable latency? Latency here is not the request and response time frame, right? The difference between request and response. This is not the latency, it is different parameter. Latency in the sense producer produces a data at a certain time, and that data will consumed by the consumer. So what is the latency between that timestamp? So that is the latency here. So what is a tolerable latency for us? Is it 1 hour? Is it 2 hour? Is it 1 minute? Is it 2 minute? Is it 3 4 hours? Is it one day? Depending on the different use cases, this latency parameter can vary, and from that we can decide which model or which architecture we need to apply, right? So basically, one is producer consumer count, second is latency parameter, third is set of rules for ranking the feed, right? So basically, as I said a couple of minutes back, in the Facebook feed system, of course there are some set of algorithms, set of rules on which this algorithm works, and based on those algorithms you will see the actual post, right, in your landing page. So that is another parameter that a user or the requirement or the client or the use case needs to answer, right? So this is another parameter. uh, will the feed be infinitely long or of the fixed length? So basically that is what is size of post, right? So that is also a one parameter that we need to answer when we are designing the such system. Last is whether or not ads are part of feed monetized feed service or. So this is again the business domain, I'll say, because as we know, Facebook is not only social networking, but it is a marketing platform also, right? Business marketing platform also. So that ads and things like that, we need to monetize that to some extent. So that is also a one of the parameter. But uh, at the beginning, we can just have a couple of above three questions, not fourth, and I mean above four questions, one to four. Fifth, you can just nullify or put it aside because it's a different perspective. But these are the questions we need to first answer to ourselves, right? Then we should start building the architecture for us. So this is the basic fundamental I wanted to create you before we dive into the uh, Facebook system. So now let's go to the next slide, and which is again this the requirement analysis, right? So basically, what is the actual requirement here? Let's say you and I combinedly designing a Facebook fit system, and what is the functional requirement? Functional requirement is very simple. User should be able to create a post. That is the first one. So basically, here you can see there will be API gateway, there will be post service, there will be post database, right? So user should be able to create a post. So that is one. Second, user should be able to follow or make a friend or follow the people. That is the second request. So again, you can think like if you are already coming from the software background and you have much, I mean, microservice working with the microservice architecture, then you can just imagine there will be some API gateway, there will be some post service, there will be some post database, then another same through that same API gateway will be talking to the follow service or friend service, whatever we can give a name, but then there will be follow table, so that will maintain a relationships and between the users. So this is second functional requirement. What is third? User should be able to view the feeds, right? Whatever post, whatever data is generated by the user, that should be retrieved by the relevant consumers, right? So relevant friends. So that is the third functional requirement to view feeds. So post service, feed service, follow service, that will talk to this data tables, and then that will be uh, the whole start to end cycle, right? So this is the basic three functional requirement. So what others, right? We can think of this is just a high level diagram I show. Others is the database part, right? So because if you know the design and architecture, and if you are aware of that, then I wrote one good sentence I took from the Google, and it's really whenever I am designing some system from my side, I just usually think in that direction. Basically, computer science is science of abstraction, right? If we create a right abstraction, right layering, then behind the scenes, whatever process we do is just a simple. So basically, abstraction is creating a complex thing into a layer, and then that layer will easily presented or easily uh, implemented or executed. So that is the main uh, thing that I perceive from this. So basically creating a right model. Model means database system, data storage models, data structures, whatever you want to uh, name for that, and then right design, right? So basically right architecture, system design. So that will solve everything, right? If we are on perfect path of that, we follow the perfect standard in that, then rest of the things are just in the 1%. 99% we have achieved our goal. So in our case, Facebook fed system, these are the some tables. This again, remember, this is very high level we are talking, right? So there are number of database, different categories of database, and different things internally Facebook is using, right? But just to showcase the dimensions, just to open up the angles, aspects, we are thinking like that. This, sorry. So in terms of database, there will be user table, there will be post table, there will be friends table, there will be post users tables. So this is just I'm taking a reference of SQL database, right? In actual, Facebook uses MySQL for persistent storage, right? So this is another requirement. data models we need to figure out. Then once we figure out the data models, once we figure out the functional requirements, then third item is to figure out the non-functional requirements. I have not listed down that, listed down here, but what are the non-functional requirements? So basically, let's say I say I would say the uh, latency, right? In the time difference between producer producing the post and consumer get the post, the latency between that I need is 1 minute. So that is a non-functional requirement. Let's say for every request, I should only wait for 500 milliseconds, right? I shouldn't wait more than that for the my request. So that is again the so, as I said, this kind of requirements are non-functional requirements. So, I have not listed that here, but we can imagine or we can think out this requirement also, right? So, this is all about requirement analysis, and now let's switch to the processing block. Yeah. So, we have pass through the figuring out the actual requirement. What is the requirement? Again, let's me remind that user should be able to create a post, user should be able to make a friend, follow people, and user should be able to see or view the feeds, right? So this is the functional requirement. So what is the process flow? Again, we are just talking at very high level because as we move ahead, I'll show some data, I'll present some data with you guys. So you'll understand how complex or how not easy to design this such kind of system is, right? So as Facebook right now doing. So processing workflow, again, simple, this is create workflow. It will start from the user will create a request. So basically it will come to the backend API gateway, then load balancer. Again, here also there are a different internal process. I don't want to highlight each and every process right here, but just the high level we are seeing this, right? So load balancer that will come to post service that will ingest the data to post user database, and likewise we have the data. So one uh, important informations that I want to highlight here is, right, this is the data based on 2023. So around 3 billion monthly active users, MAUs are there in the Facebook, right? So in all the relevant platforms of the world, this is the highest among those, right? So this is roughly 37% of the world's populations. So imagine how many users are daily actively participating in this process, right? So this is just to showcase, just to open up the dimensions of your thinking, right? So this create flow. Once data is stored here, of course there will be uh, some background process, right, just after ingesting the data to relevant database, because we cannot have the system like it's stored and then it's just fetched from that only, right, original source only. Of course there will be some background process. So then after uh, it will create some stream processor, it will trigger or it will generate streams. Basically we can imagine of having Kafka or any other stream processors. So that will do a different processor. I highlighted two here: moderation, right? Moderation is validation, or we can say the checkpoint, right? See, so basically to categorize the post, to categorize the data, to categorize the informations, to test out is it valid or not. So things like that are done here, moderation process, and then enrichment. Let's say user posted in some image. So if you want to enrich that image to some extent, then enrichment is the another process. And not only this two, but of course there will be multiple processes, but I highlighted just two things here. So again I want to share another information, that is this one, right? So in a minute, what number of activities are actually happened in the Facebook system, right? So just this is the information. On every minute, there are 400 people's new peoples are joining, right? So basically, we can see new accounts also because people can have multiple accounts, right? So new peoples are joining uh, every 60 seconds. There are 5.1 lakhs comments are posted, 2.93 status are updated, 4 million posts are liked, and 1.36 photos been uploaded. So these many activities are actually done in the single minute, right? So now you imagine the scaling, right, or complexity of the system to maintain, right? Servers and infrastructure and uh, backup, everything, right? So there are lots of things. So this is the complex how the system is for Facebook Fit. So then after this moderation enrichment data is posted to post metadata. So this is the normal simple flow of the create workflow. Let's again, I want to share another information that Facebook has 500 read per each write. So basically, it is read operation is 500 times write operations. So again, this is the another parameter to consider while designing and Facebook feed system. So yes, with that said, this is the second approach or sorry second workflow, that is a retrieve workflow. Once it is posted, how you consumer can retrieve the data. So this is the uh, overall process. If you and I design a system, normal system, which doesn't has millions of users, but imagine it has just thousands of users and not this much post, but normal post are happens and normal retrieval happens. So its workload is really low compared to the Facebook. So in that case, this is the perfect system, right? So user will come to application, request will propagate to load balancer, then through the load balancer, it will propagate to feed service. What feed service will do? It will first find out the friends of that user, right? Friends, followers of, I mean, whom he or she following. So like information is fetched from the database, then it will talk to post service. Post service will give the post related to those friends from here. Post will be fetched, and then third, according to some set of rules, of course, that will be aggregated, filter, and ranked, sorted in proper order, and then it will feed or it will respond back to the user, right? So this is the retrieve workflow in the normal stage, in the normal operations, normal, but this is not actually the solution which will target our exact requirement, right? Because this will call the multiple HTTP calls inherently. One is for post service, then in the ranking service. Again, in the post service, there will be multiple underlying database calls and things like that. So again, this is not tolerable. We need to have some better systems. So what is the solution then? So can you imagine the solution? The solution is very effective and simple. Let's just simplify that complex retrieval to like this. So we have load balancer, we have feed service, and that feed service will talk to the cache database, right? In memory database, whether it can be Redis or any other in memory database you take. So it will have the in-memory database, and then the it will again will talk to post service when and where needed. So basically, let's imagine, just for the sake of simplicity, this Redis will store the data in this format. It has user ID, and that user ID will have the list of post ID to which when user request, right? So this post will be fit to that user, and also this post ID is already in the sorted order, right? So then this will simplify the complex problem, right? So basically, as I said, right abstractions will solve the complex problem. So this is perfect abstraction we have created. We have inserted one cache memory database that will have sorted post IDs for the specific users, for the each and every users. And when users request that, it will fetch the list of post IDs, and then it will find the post from the post service according to those IDs, and then it will feed the users, respond back to the users. So again, you started in thinking in that direction. Then why can't we just insert the post directly to the in memory database? Yes, that is also a solution. And in actually, Facebook does this, but just to simplify this, I have shown like this. So this is the retrieval updated workflow that we created. But again, the question is how, right? So basically, as we said, use this will be using we are leveraging this, like there will be user ID and that user ID will map to list of post ID. But to insert that in the Redis, we need to do some process, right? So that is the another workflow that we need to understand, and that is this one. So let us start from this again. This is a simple process. The first line, first year, you can see this is a simple process. The user create a post that will come to post database. Stream processor will moderation, enrichment workers will do some process, and then metadata information is stored here. Again, from that, this is the additional flow, right, that I've added. So that streams will go to the stream processor. That stream processor, again, it can have multiple workers, right? So that stream processor can talk to post service, ranking service, feed service to properly fetch the data, aggregate the data, filter the data, rank the data, and then the final version of the data is, as I said, it will be stored to that in-memory Redis cache. And from there onwards, if user requests the retrieval, request the data, then again that will become to feed service, and feed service will just directly fetch the data from the cache. So this is how, uh, again, if you remember or if you recall our architecture models, and you will imagine this whole system, right? So this system, right, this is actually the push model, right? On right, on every write, we are generating a stream. That stream will do some trigger some workers. That worker will do some process, and but that is ingested to the Redis. And again, if we need to do at schedule time, let's say, uh, if the requirement is like this, let's say user posts the data, but the consumer can have that data after 1 minute or after 1 hour also. Sorry, not 1 minute, but 1 hour also. Then you can schedule a job of 1 hour, or maybe less than 1 hour. That schedule job will trigger the stream processor that will find the relevant data, process, and already make them in sorted order and ingest them to the appropriate data formats in the Redis, and then that will be fit to the consumer, right? So this is push model. Again, we can have combination of push pull model depending on the requirements, because even in the Facebook, if you categorize the users, then there are some categories, right? Some users are normal users like you and me. Some users are celebrity users. So of course, so celebrity users can have different uh, architecture pattern, system design, or I should say the pipeline workflow, and normal users can have a different pipeline and workflow. But this is the overall process. Uh, the combination of basic architecture we can integrate here, and then finally we feed the users, right? So this is how Facebook feeds works. But again, I want to share some data here, right? So how this distributed organizations or distributed system works actually, because in real the users of Facebooks, right? So it's distributed everywhere. If we talk about the Southern Asia region, then there are around 5 million users. If we talk about Northern America, then there are about 200 million users. If we talk about Western Europe, then there are 80 million users, right? So all the users are distributed geographically. So that is again another challenge. And if I already shared one of the point, right? So daily active users. So in quarter four of 2023, it is noticed that there are 2.1 million daily active users. In first quarter of 2024, it is noticed that there are 3.07 billion users, active users monthly, right? So this is huge number, and to tackle this much operations, right? And if you remember one informations I shared in the previous slide, that is write weight compared to read weight. So write weight is 500 times more than the, sorry, read weight is 500 times more than the write. So every write operations, there are 500 read operations. So this is how complex it is. Number of posts, comments, likes, and everything, right? So to manage, it's very difficult. But Facebook done good, fantastic research on that, and then they come up with the one of the game changer, and that is TAO, right? So basically, TAO is the game changer for the Facebook. They, if I am not wrong, they started uh, heading in this direction in 2004, but they didn't get final version. Then that is a normal version, right? We didn't get the final outcome at the first place only, right? So they started researching more towards this, how we can scale up the system in 2004, and then around 2007, 8 or 9, I don't remember actually, right? You can Google it, but they finally come with the approach, and that is the TAO. So basically, it's graph database system, kind of graph database approach. And what is the meaning of TAO? TAO is nothing but the it is abbreviation of the associations and the objects, right? So basically, it is efficient data management, right? So our data is actually stored in the database as well as in the redis, in the cache, right? So efficient data management, also it will scale the architecture. Scalable architecture is also managed under this TAO system or TAO design principles. Then the optimized caching, as I said, how we can optimize cache caching store in a such a way that it can be easily retrieved by the user. So TAO also take care of that. So here I took this image from the official Facebook page. You can see this. Let's say imagine one. This is one post, or we can say comment, right? One post is there. So post is Alice was at the Golden Gate Bridge with Bob, and then on that post, Kathy, that is another user, uh, he or she shared comment like wish we were there, and then David likes that comment. So this is very simple, right? So how this TAO stores the data under that? So basically it will categorize the data into variations, right? One is the objects, and then association between those objects. So in this example, Alice, that is a user, is the object. Then Bob is the user, which is the object. And then Kathy is the user object. David is the user object. Again, this is the Golden Gate Bridge, is the location object. Then David likes this. Basically, that is a checking, right? When it is like, so that is another object. Then the comment, right? So this is the comment, which is object. So as you can see, in every object there are three common four common patterns. One is id, second is type, and third is name. So basically three things. So type, id, and name, right? So this is, and again, if additional information is needed, then there are location also. So these are the object, its key values, and then associations are the relation among those, right? So if Alice has liked, or Alice has liked by David, Alice comment is liked by Davis, then there will be some association among those, right? So as you can see, Kathy commented this, right? So there will be some relations among those. So these are the friends. So there are some relations among those. So this is how the one post data is stored in the cache internally using the TAO methodology or TAO principles, design principles. So this is again one image I took from the research paper. The Facebook or some fellow presented this, and I took this. So basically, objects are nothing but the nodes, we can say, and associations are nothing but the edges, right? So uh, objects are identified by the unique 64 bit of ID. So there will be one ID for each and every object, and that is unique, right? So and then type of the object, and then actual object, and then associations are identified by this pattern, right? The braces are there, then id1, the type, and id2. So this is the identified identity of the association, right? So if that, let's say this user has commented this, right? So id, this user's id is 1807, then this is the comment, so that's why its type is comment, and then uh, this comment ID is 2003, and there will be timestamp at which timestamp it is stored, right? So this is how objects and associations are linked between this on this tau system. And there will be another entity interesting API, which is association list. So this is again list of associations for the specific object. Let's say this is specific object, and for this object, these are the associations, and these associations have this, again, this is the actual object of for that association linked to, right? So and again from the timestamp, it is in short, it is ordered in which we need. So this is association list. So basically, at a very high level, this is the system or architecture. Again, this image I took from the uh, paper which is presented by those fellows. So this is a high level architecture. Will be having stateless web servers, of course. That web servers will talk to the cache, uh, Redis cache, right? So that cache will store the data as we define, as we talk in like TAO system, objects and association formats, and that cache will have objects, association list, and association counts, right? So for specific object, how many association counts are there, and that list. So that will be sharded by ID. So as I said, one post that will be under a specific shard, and that shard will have a specific ID, and that will scale depending on read query per second, right? So how much read intensity we need, read performance we need. So if we need high read operations, then it will scale accordingly. And then the bottom of that, there will be of course database. They use MySQL. Facebook uses MySQL for that, and that will be again sharded by ID, and that will shard according to the data storage, right? If write operations are more, then that will be scaled and sharded. So this is the internal process. Again, I have not delve deep or very deep insights of this domains, but this is just high level talk. And as I said, read capacity can be increased by increasing the cache machines, these cache machines, and write capacity is increased by the database, right? So this is how they separate the concerns, read concerns and write concerns. Both are separated. Cache will take care of read, and then database will take care of write. So this is how they manage a 1 billion query per second, right? So this is very high number, right? And many petabytes of data. And the real reason for that is nothing but this TAO. So hopefully I covered almost everything at very high level. Again, this is very uh, I shouldn't say knowledgeable session, but just the informative session, and which will explores the how AWS abstractions, sorry, AWS not, sorry, Facebook feed systems abstraction is designed, right? How it is designed, what are the core parameters of that, and what is the core architecture behind the scenes, and how the processing flow or workflow, starting from producer to consumer, it happens in the Facebook, and how many number of queries they handle, and what is the actual technology behind the scene, right? So everything, every aspects I tried to cover in this. Basically, as a normal engineer, we shouldn't need to think at this scale, but if we know how they plan or they design the system at our level, right, at our requirement, we can also design and we can also think in that this direction, right? So this is the main purpose or objective of this session, right? So if you are a solution engineer or if you are a senior developer who is working on this team or system and has a frequent requirements from the client, from the projects, and he wants to design a good system, so how he or she should design, right? How he or she should head in the right direction to have the proper abstractions, and if you have abstracted your system perfectly, then behind the scenes, it doesn't matter how many complex it is, but you can implement it easily, you can execute it easily, and you can present it easily, right? So this is the core purpose of this. I hope I tried to cover, I covered all the aspects that you need as a solution engineer and as a senior developer. So these are the some references from which I took the data. And yes, lastly, thank you. Thanks all of you for your time and watching this till the end. So hopefully you will like this.